Welcome, everyone. I'm glad that you're joining us today for this interesting and, of course, very important topic, especially in the finishing industry today. So looking at the contents of what we'll be discussing during this webinar, first we'll start with conventional pretreatments and some of the associated costs that come with those. Then we'll discuss process advantages of sustainable pretreatments before moving into the Atotech portfolio, discussing most specifically our cleaners and conversion coatings. And then to finalize the webinar today, we'll talk about identifying cost and CO2 reduction opportunities before finally going over some case studies of applicators that have implemented these processes. So starting first with conventional pretreatments. As we know, cleaning is the essential first step for any good pretreatment process and really is critical to ensure the highest finished part quality. To effectively remove the oils and fluids that are typically used in forming, stamping, and cutting operations for metal production parts, applicators traditionally use an alkaline cleaner for these processes. The fluids that are removed during the cleaning process become emulsified by the available surfactant in the cleaner chemistry itself. The result is a gradual loss in the cleaning efficiency over the usable life of the chemistry. And you can see that depicted in the diagram on the right, where we see the time duration or oil content along the x-axis and the cleaning performance along the y-axis. As you would expect, you would achieve 100% cleaning efficiency at a new cleaner makeup. And as time goes on, the cleaning efficiency will gradually decrease until there's a point which necessitates a new cleaner makeup. So without the proper process control, poor cleaning can have a really big impact and lead to diminished final part quality. Most conventional alkaline cleaners do function best when they're operated in a temperature range of 55 to 80 degrees Celsius. Especially in spray pretreatment systems, the energy requirement to maintain that operating temperature can be quite high. So with the dramatic increase of price of energy, especially in the last few years, the impact on the overall operating costs can be greatly impacted because of this. An increase in the carbon emissions or carbon footprint is immediately associated with this high level of energy consumption as well. Looking at conversion coatings, so after the cleaning process itself is complete, it is of course necessary to protect the part. And this is critical for enhancing the corrosion and paint adhesion qualities of the final production parts. Traditionally, applicators have implemented iron or zinc phosphates, and they have been used to provide the necessary coating to meet applicators' performance requirements. These processes have endured in the paint applications for many years as a result of several factors. They have a well-established history at existing applicators. They're written into existing specifications. This is especially true for automotive industry as well as construction and agricultural equipment. And they are relatively easy to use. Much like cleaners, phosphate pretreatments do often operate at elevated temperatures, and in the context of conversion coatings, typically we're discussing 45 to 65 degrees Celsius. And again, this too attributes to a high energy cost and associated carbon footprint. In addition, phosphate pretreatments can generate a large amount of scale and sludge as a byproduct of the chemical reaction with the production parts. This sludge and scale can block spray nozzles and risers, and if it's left unaddressed, can lead to poor spray patterns and part coverage. It can also coat heat exchangers and burners, which will ultimately reduce the heating capacity for the process itself, which can impact the final part quality. So along the bottom of the page here, you can see some examples of the scale and sludge that is formed on the risers and nozzles, as well as inside the chemical tank itself, which can impact the process. And then finally, the maintenance requirements that come along with phosphate pretreatments can be tremendous as a result of that. So there has been advancements in the coating industry within the last, say, 10 to 20 years that have introduced newer technologies, and most often you hear those referred to as thin film pretreatments or nanoceramic pretreatments, and those have been introduced and implemented at applicators to overcome some of the disadvantages of those phosphate pretreatments we just discussed. However, there are some processes, or these processes can still have some negative aspects associated with them. Those include process stability concerns, operating parameter sensitivity, whether we're talking about time, temperature, or concentration, a low tolerance for contamination. They can be susceptible to incomplete coating deposition without adequate surface cleanliness. And as we discussed, cleaning is the essential first step. And on the right side of the page here, you can see an example of a thin film pretreatment that is exhibiting voids in the coating deposition itself as a result of this poor surface cleaning and/or poor rinsing. They can have a high requirement for superior water quality, both for the makeup chemistry itself, as well as the rinses, both before and after the conversion coating stage. And as a result, these thin film pretreatments can exhibit elevated chemical consumption, which ultimately will increase an operator's cost for the whole process. So now we'll discuss some of the process advantages of a sustainable pretreatment approach. So a conventional pretreatment often will have a low unit price, which makes them at face value a very unattractive option. However, the cost of operation really must be considered. It can have a big impact on all departments involved in the process. Whether we're talking about production or engineering departments, HES, as well as purchasing. And this is, this can impact those departments in the decision to switch to a next generation pretreatment. And on the right, you see the image weighing the price versus value of a process. So why do some of these newer technologies for pre-paint application have a higher unit price? Firstly, it's because they're more sustainable. So with limited or no regulated elements or compounds in the chemistries, this helps to simplify the wastewater treatment operations and reduces the overall wastewater treatment costs as well. They are more concentrated. So with a lower product, what this relates to is a lower product consumption, and this also means shipping less material from a production site to the applicator, and a lower cost of operation. And with shipping less material, as we all know, the freight costs have increased quite dramatically in the last few years as well. And this means that there's less of an impact on the applicator for the freight costs associated with shipping material as well. And then lastly, with advanced materials. So this is affording the capability to achieve long life and low temperature operation for that improved carbon footprint and improved part quality as well. So next generation sustainable pretreatments can overcome many of the negative aspects that we've discussed with some of the conventional pretreatments. Those include a longer solution life, lower operating temperatures. They, in general, produce less waste. They definitely support with less maintenance requirements, and in most situations can offer a more reliable performance for the applicator. So selection and implementation of one of these newer generation pretreatments does require a systematic approach organizationally. We talked about all the different departments within an organization that can have an impact on the process, and involving all of those departments together to select a process is going to be the best way to identify a process that offers benefits for all. The applicators must consider the overall cost of ownership for their process rather than simply the unit price itself. Again, going back to the price versus value argument. So the case for change. Conventional pretreatments obviously it can have a big environmental and operational burden for an applicator. And as a result of this, manufacturers across the globe are implementing initiatives seeking greener solutions, especially as a countermeasure against global warming. And we see, very public acceptance or implementation of these sustainable initiatives coming from many different industries. So there's several key factors that are driving this technology change for a lot of these corporations. The first one is labor shortages. Obviously, as we've all been impacted by the pandemic the last few years, we've had labor shortages at one time or the next, and this can definitely have an impact on our production process. And by not having enough staff, this means that the capability of maintaining our maintenance schedule can be impacted, and with not having the proper maintenance schedule, this can ultimately impact the final part quality. Corporate social responsibility as well. Here we're talking about the impact on the environment and the employees around us and everything. So ensuring that that applicators are implementing processes that do not have these elements or compounds of concern. Conservation of natural resources. Here we're talking about things like water and natural gas for operating all of the processes. And lastly, the carbon footprint. Here, whether we're talking about the energy consumption or again, the freight costs associated with shipping large amounts of chemistries around the world from the chemical suppliers' production sites. So now we'll get into Atotech's approach to sustainable pretreatment technologies and discuss some of the processes that we offer to our applicators. So UniPrep is our solution for applicators that are seeking a more sustainable alternative to conventional cleaners and degreasers. So UniPrep cleaners, which are formulated with a robust builder and surfactant package, are designed to function at lower temperatures than conventional processes. And again, what we're talking about with conventional processes is a typical operating range of 55 to 80 degrees Celsius on the cleaners and degreasers. And we're able to achieve this without compromising the cleaning performance. UniPrep cleaners can also achieve extended solution life with the use of special additives that are going to support with naturally degrading the organic soils that are removed from the substrate surface during the cleaning process. With these long life capabilities, we're able to further extend that with the integration of our specialized oil elimination equipment, which we refer to as UniPrep Atotech. So UniPrep is going to offer several key benefits when considering a transition from a conventional cleaner system. The first, which we've discussed a little bit already, is the low operating temperatures, which can result in substantial energy savings and reduced carbon footprint. With long life benefits, these include increased productivity, supporting the reduced labor requirement that we've already discussed a little bit, reduced wastewater treatment burden by having an extended solution life. This obviously means that you're going to send less chemistry to wastewater treatment. Improved chemical consumption. In most scenarios, applicators are able to achieve a 2 to 4 time cleaner life extension as compared to a conventional process. And as we mentioned in the previous slide, the systems approach with the integration of UniPrep Atotech equipment makes a no-dump cleaner a real possibility for applicators. And then finally, improved cost of operation. With this, we're able to maintain a stable performance throughout the cleaner life, and this is going to provide a much more consistent result while minimizing defects. So if you think back to the diagram that showed the typical cleaner life or cleaner life cycle of a conventional cleaner, compare that to the diagram you see on the bottom right of the page here. You can see that the cleaning consistency and performance is much more stable with the UniPrep system itself. So with the UniPrep cleaners, we're also able to reduce the chemical oxygen demand, or the COD levels. And the COD itself is going to measure the organic compounds in solution, that being the oils that are removed during the cleaning process. So you can see in the graph on the bottom of the page here An example of a study that was done of a conventional cleaner system versus a Uniprep long life system. The Uniprep long life system being the green line along the bottom. And here you can see in this study that we're able to reduce the COD by as much as 46% across this nine-week life cycle. So here is just an example of a conventional cleaner system exhibiting a high amount of surface oil on top of the degreasing solution. And then with the Uniprep cleaner system, you can see that the amount of oil is significantly decreased with that capability of being able to naturally degrade those oils. Next is interlocks, and interlocks is Atotech's family of zirconium-based conversion coatings. So interlocks is a chrome-free and phosphorus-free process that is designed to offer superior paint adhesion and corrosion protection for a wide variety of applications. Interlocks can be used for protecting ferrous and non-ferrous substrates in powder applications, liquid paint applications, E-coat, KTL, ED paints, and even in combination paint applications where applicators are using multiple paint types. And those are implemented across many different industries. Inclusive of those industries is automotive, whether we're talking about two-wheel, three-wheel, or four-wheel vehicles, truck and bus applications, white goods and appliance, furniture, construction, agricultural equipment, as well as transportation, and lastly, architectural aluminum. Interlocks also offers the ideal solution for applicators that are trying to identify a multi-metal pretreatment process. So if we look at the primary benefits that can be improved on with interlocks in comparison to traditional phosphate-based pretreatments, those include the fact that they can offer a similar paint adhesion and corrosion resistance performance. They, again, are suitable for multi-metal applications. They can offer energy savings and reduce carbon footprint through the reduced operating temperatures. And on the right side of the page here, you can see a table kind of exhibiting some of the traditional process parameters associated with a phosphate versus our interlocks processes. There is minimal or no sludge formation, which is going to support applicators with reducing their maintenance requirements. They can offer a longer solution life and generate less waste, which of course is going to reduce the burden on wastewater treatment operations. And they are more sustainable. Here we're talking about, in comparison to a phosphate pretreatment, the elimination of phosphorus, zinc, nickel. When we compare interlocks to some competitive thin film pretreatments, some of the process advantages typically observed include simplified process control. Here, interlocks can truly be operated by controlling the pH of the process itself, as well as the process stability. They do offer a stable performance at a wide, say, ambient temperature range. And for us, we consider an ambient temperature range for our interlocks conversion coatings ranging most normally from 20 to 40 degrees Celsius, but can be operated even at lower temperatures as well without impacting the overall process or part quality. They are, again, suitable for multi-metal applications. They do improve on the bath life as they have a higher tolerance for contaminants. They do offer a low product consumption, and we'll see some examples of that later in the presentation. They do have a decreased sensitivity to dry-off temperatures. They're less sensitive to the method of application. Here we're talking about time, temperature, and concentration. And less sensitive to contamination and water quality, again, being for the makeup and the rinses, both before and after the conversion coating. And then overall, they provide a more consistent paint performance and corrosion resistance as well. So now we'll go into the economics of sustainable pretreatment and identifying some cost and CO2 reduction opportunities. So what we'll see here is three different examples of theoretical applicators that have considered a transition or implemented a transition from a conventional process to one of the Atotech processes. So here you see in this example, we're considering a 5,000 liter degreasing tank. And in this scenario, the applicator is producing about 500,000 square meters per month production. And the ambient temperature operation of 22 degrees Celsius. You can see with a conventional degreaser, we consider a cost of X US dollars per kg with operating parameters of 55 degrees Celsius at 5% concentration and a 30-day bath life. With the Uniprep cleaner, we consider that the cost will be about 1.5 times higher, but we're able to achieve lower operating concentration, at 3% lower operating temperature at 35 degrees Celsius, and an extended solution life of 90 days. So here you can see in this example the different costs that are associated with each of the different steps here. First, starting with the first column, the chemical cost, you can see that with the conventional degreaser, the associated cost of the chemistry is around 130,000 US dollars. And the cost that with the Uniprep cleaning system is reduced by 19,300 US dollars, or about a 15% reduction. When we look at the energy cost, reducing the operating temperature from 55 degrees Celsius down to 35 degrees Celsius can have a big impact. And obviously you can see here that we're able to reduce the energy costs by almost 35,000 US dollars per year, which is a reduction of about 59%. Then if we looked at the running cost, which is in the third column here, you can see that if we look at the conventional degreaser, it has a running cost of about 0.3 US dollars per square meter. And with the Uniprep cleaning system, we're able to reduce that by about 53,000 US dollars, which is the summation of the chemical and energy costs, which is a total reduction of about 28% for the applicator. When we look at the spent chemical sent to wastewater treatment, this is coming exclusively from the extension of bath life. Here we can see that we're able to reduce that by about 70%. And then the associated costs by reducing that wastewater treatment burden is about 70%, or about 10,000 US dollars. Then lastly, looking at the carbon emissions, the CO2 emissions, the associated carbon footprint with the conventional system is about 212,000 metric ton per year. With the Uniprep cleaning system, by reducing that operating temperature down to 35 degrees Celsius, we're able to reduce the CO2 emissions by 58%, or 124 metric tons. So in total, the overall process savings for the applicator here, if we include the chemical, energy, and wastewater treatment costs, is almost 63,000 US dollars. So if we move into the example of an applicator considering a conversion from a zinc phosphate to our Interlox zirconium-based pretreatments. Again, very similar scenario here, 5,000 liter operating tank with 500,000 square meter production. If we look at the zinc phosphate process, typically we'll have a cost of X US dollars, operating at 2%, 55 degrees Celsius operation, and 120-day bath life. Here, the big difference being the chemical consumption of 12 gram per square meter. This is quite common of a phosphate-based pretreatment. And then if we compare that to the Interlox conversion coating, yes, it is true that the zirconium-based pretreatments have a higher unit price. As you can see here in this scenario, we're considering a 4-time greater unit price. Similar operating concentration, but here operating at ambient temperatures and a similar bath life. Lastly, looking at the product consumption, quite typical to see the Interlox conversion coating achieve a chemical consumption of around 1.5 to 2 gram per square meter. So now looking at all the associated costs that come along with considering a conversion from a zinc phosphate to interlocks. Here we can see in the first column the chemical cost. We're able to reduce that by almost 70,000 US dollars per year, which is almost 50%, right at 47%. Looking at the energy cost, we're able to completely eliminate all energy demands that are associated with the conversion coating step itself, which in total is equivalent to about 62,000 US dollars. Then lastly, if we look at the running costs, which again is the summation of the chemical and energy costs, the total running cost is reduced by a total of almost 132,000 US dollars, which is equivalent to 63% of the total operating cost. Looking at the estimated sludge or byproduct that is generated from the process itself, with the zinc phosphate process, we can typically see in such a scenario about 30,000 kilogram per year from the process, and with the interlocks process, greatly reduced by about 96%. And then lastly, looking at the CO2 emissions that again are coming exclusive from the pretreatment system itself, by being able to achieve ambient temperature operation, we're able to completely eliminate all emissions associated with the pretreatment process. And then lastly, if we consider an applicator that is transitioning from a thin film pretreatment to interlocks, we can see that again, the operating conditions still quite the same. If we look at the comparisons of the competitive thin film versus interlocks, we consider here that the unit price will be about 2 times higher. Similar operating concentrations and operating temperatures at 2% in ambient temperature. But here we're able to increase the bath life quite a bit, as well as reducing the chemical consumption. So what does that equate to for an applicator considering a change? So the chemical cost can be greatly reduced in this scenario by reducing it by about 50%. And most of this is associated with the reduced chemical consumption. Here we see that for both processes, because they're operated at ambient temperature, they have zero energy cost associated with them. So the total running cost is exclusively, differences are coming exclusively from the chemical costs. But here you can still see that we're able to reduce that by about 50%. The estimated sludge or byproduct, again, is going to be similar. And then again, the CO2 emissions from the pretreatment itself will be identical because of the ambient temperature operation in the conversion coating step itself. So last portion of the presentation today, we'll be going into some case studies of applicators that have aptly implemented the Atotech processes and some of the operational benefits that they've observed from that. So the first is a cooking appliance OEM. So this applicator has 4 production lines, 3 of them being enamel lines and 1 paint line with 7 total conveyors. In this example here, we'll focus pretty much exclusively on the paint line for the example. Atotech in this scenario has been the pretreatment supplier to this applicator for about 10 years. And their key drivers for change at that time were reduced chemical consumption, improving the process stability, and their corporate sustainability initiatives as well. So here's the example of their paint line. And we'll focus here on the bottom left side of the page, looking at some of the process benefits. So here we were able to reduce the operating temperature of the cleaner from 50 degrees Celsius down to 40 degrees Celsius. We're also able to eliminate the heated rinse that came after the cleaner, which was necessary for their process, and also able to completely eliminate the heat requirement for the conversion coating. Here you can see the iron phosphate was operated at 50 degrees Celsius, and with the interlocks conversion coating, able to operate at ambient temperature. So the key benefits that the applicator observed from the paint line is the elimination of the sealer stage requirement. They were able to reduce their water consumption by about 140 million liters annually. They were able to reduce their scale and sludge formation from the phosphate process by about 12,000 kgs. And they were able to achieve 100% elimination of energy required for heating the conversion coating stage as well. Looking at some of the other advantages that are split across all 4 lines that the operator has in their facility, you can see that if we look at the far right side of the page here, with the capability of extending the cleaner life with the Uniprep long life cleaner system, we're able to significantly reduce the amount of cleaner makeups required on an annualized basis. The other benefits that the applicator observed was a reduction of almost 90,000 liters annually for the makeup and replenishment requirements. And then they were also able to reduce their cleaner replenishments by about 18% as well. So to summarize this applicator, some of the key benefits that they observed, again, was the reduction in chemistry and wastewater treatment burdens. Looking at the energy requirements or energy savings associated with the process, they were able to reduce their energy or improve their energy savings by about 44,000 US per year. And they were also able to reduce their carbon footprint by about 440 metric tons as well. They were also able to improve their labor requirements, reducing their maintenance process. And in total, the applicator observed about 270,000 US per year savings from all of these benefits. Case study number 2 is a tier 1 shock absorber manufacturer. This applicator is operating multiple pretreatment lines with various paint types for several different OEMs. In this scenario, they have exclusively implemented ambient temperature cleaning with Uniprep to replace their conventional cleaner system, and this was achieved in 2021. And their primary driver for change was a corporate goal for carbon neutrality by 2030 as their key target. So here's an example of their line setup. You can see that if we focus here exclusively on the cleaner stages, they were able to reduce the operating temperature from 55 degrees Celsius down to 30 degrees Celsius, which eliminated all of their heating requirements for both stage 1 and 2. With multiple cleaning quantification tools, they were able to exhibit an equivalent cleaning performance, even at ambient temperatures. And this had absolutely no impact on their paint qualities. And so with this, they were able to continue to meet the OEM requirements that they were achieving. And this is their first step in their pursuit for carbon neutrality. So here on the right side, you can see some of the costs that were associated with the process. You can see that on an annualized basis, the existing chemistry had an associated cost of around 90,000 US per year. With the implementation of the Atotech system, you can see that we're able to reduce that by about 20%. And pretty much all of that is coming exclusively from the capability of reducing the energy requirement for heating the cleaner degreaser stage. Case study number 3 is again another appliance manufacturer. In this scenario, they are a refrigerator OEM. They're producing upwards of 1 million square meters per month. They did utilize a nano ceramic pretreatment in their 6-stage pretreatment washer. And in 2016, they implemented interlocks as well as Uniprep for their system. For this example, we're going to focus pretty much exclusively on the conversion from the nano ceramic to interlocks. So here you can see the process differences from the 2 applications. With the conversion from the nano ceramic to interlocks, we were able to reduce the chemical consumption by quite a bit. A total of 7 times lower chemical consumption for the applicator. We were able to extend the solution life from 6 months to 12 months, which is a 2x bath life extension for the applicator. And then lastly, we were able to reduce the operating cost of the pretreatment itself as well by about 52%. And then the last case study, which is a microwave oven OEM, they were utilizing a conventional cleaner and zinc phosphate pretreatment. Their primary goal was to replace their existing process with a low temperature alternative to eliminate their necessity for replacing their boiler system. The existing chemistry was not optimal for multi-metal pretreatments, and so in 2021 they implemented both uniprep and interlocks for their system. With this, they were able to reduce the operating temperature of the cleaner from 60 C to ambient, and for the coating from 45 degrees C to ambient temperature as well. This increased their bath life by 2 times. They were able to eliminate their surface conditioner, which was required for the phosphate process. Again, it was optimal for their multi-metal needs, and it was able to support the applicator to completely cancel their boiler replacement project, which equated to about 120,000 US dollars per year in savings. Lastly, they were able to achieve an operating cost of around 3 cents per square meter, which exceeded the cost target of 5 cents per square meter, and surpassed the conventional pretreatment operating costs as well. So again, here you can see the cost improvements that were achieved from the process by completely eliminating the energy requirements, the cost associated annually for the new boiler system, as well as some of the additional costs. Despite having a higher chemical cost, we were able to significantly improve their overall operating costs for the process. So to summarize, here, just a quick example of some of the different technologies that Atotech offers. Again, we focus pretty much exclusively today on our uniprep and interlocks processes. Just to introduce some of the other processes that Atotech offers for paint applicators, especially in our paint pretreatment processes, is our uniprep AC descalers, which is ideal for weld and laser scale removal and operates at near neutral pHs. In our pretreatment subgroup, we also offer interprep performance enhancing sealers, as well as unicoat single step cleaner coaters. If we look at the painting applications, Atotech offers our clear aid processes for superior paint overspray treatment. And then lastly, for paint removal, our sustainable paint removal processes for ferrous and light metal applications as well.